Mathematicians. Today we're going to be talking about parallel and perpendicular lines, and we're going to be tying that into slope-intercept form. So just to review, parallel lines never intersect. Doesn't matter if they're diagonal, horizontal, vertical, right? They never intersect. Perpendicular lines form a T. They form a right angle, form a corner, all right? So perpendicular lines, all right? So what we're going to do is talk about the relationship of those in terms of algebraic equations. And then we're going to start practicing with them. So that's our goal for today. So just a couple of things that I want you to get out of this is that parallel lines have the same slope. Parallel lines have the exact same. Right? So if a line has a slope of 5 and it's parallel to another line, the slope of that line is also 5. For perpendicular lines, it says their product of their slopes is -1. Now, another note that I want you to write into this is that the slopes are opposite. That means if one's positive, one's negative, and the reciprocal. Okay, so they're opposite and reciprocal. Opposite and reciprocal. All right, so parallel and perpendicular lines. All right, so let's talk about parallel lines right here. So all vertical lines are parallel because they go up and down and they never intersect. All right, if we have two non-vertical lines, they have the same slope. Same slope. Parallel lines, same slope. Same slope. And this is why it's important to write equations in slope-intercept form, because when you write them in slope-intercept form, you can see the m in each of the equations to determine if they're the same. So this is why we're working on rewriting equations in slope-intercept form, is because we got to figure out the slope. Perpendicular lines, all right? So vertical and horizontal lines are always perpendicular. Remember, a vertical line has a slope of undefined. A horizontal line has a slope of 0. They're always going to be perpendicular. And like we said, that the product of the slopes of non-vertical lines are perpendicular if their product is -1. Again, I'm going to write this here. They need to be opposite and reciprocal. So we should probably reciprocal. We should practice a little bit. They give us one example here that if the slope is 4, the perpendicular slope is -1/4. You take the opposite sign, so you go from positive to negative, and then you flip it. So it becomes 1/4, okay? If I have a slope of 2/3, then the opposite reciprocal is going to be negative because it goes from positive to negative, and then it's going to be 3/2, -3/2. Or if I have -6, to find the reciprocal, it's going to go from negative to positive, and this is really 6/1. So when I flip it, I get 1/6. It's going to be 1/6. All right. So we're going to work on finding the slopes of parallel and perpendicular lines. So when we look at here, all right, let's take a look at this first. We're going to practice it. Give the slope parallel to the slope in this line. So when I look in this equation, my slope is -3/2. Parallel lines have the same slope. So the slope of the new line is -3/2. -3/2. It stays the same. This is why it's important to have equations in slope-intercept form. All right, here my slope is 4. It's before x. So m equals 4. The slope of the new line that's parallel has a slope of 4. Y equals 5. In this equation, we think, hey, right? Horizontal line, it's got 0 slope. the equation of a line that's parallel to it has a slope of 0. So my slope equals 0. Now this next one says give the slope perpendicular to the given slopes. All right. So when I look at this one, the slope is -5. So I have to take the opposite and reciprocal. So the opposite is going to be positive. The reciprocal, so that's 5/1, becomes 1/5. The slope of the perpendicular line is positive 1/5. Number 2, or letter B, the equation is x equals 5. So VUX, right? A vertical line, undefined slope, x equals. So to find the slope perpendicular to it, it needs to be horizontal. So that slope is going to be 0. And the last one, we have a slope of 4/3. To find the slope opposite and reciprocal, we flip it. So it's 3/4, and we make it negative. So it's -3/4. The slope of the line perpendicular is -3/4. Okay. All right, here we go. Indicate the slope of the line parallel to the given line, then find the slope of the line perpendicular to each line. So y equals 2/3 x minus 8. So when I look at this, it's in slope-intercept form. I know my slope. If my slope is parallel to it, it stays as 2/3. If it's perpendicular, I take the opposite and I flip it. So it becomes -3/2. It becomes -3/2. Number 2, oh, bummer. This one isn't written in slope-intercept form. I need to change it to slope-intercept form. So what I'm going to do is I'm going to write it down here, and I need to rewrite it. So it's y equals mx plus b. So I'm going to subtract 6x from both sides. So 5y equals -6x plus 12. I'm going to divide everything by 5. So y equals -6/5 x plus 12/5. Now I have my equation and I can figure out my parallel and perpendicular slope. This is why writing equations in slope-intercept form is so important. So the slope of this line is -6/5. A parallel slope is the same thing, -6/5. The perpendicular slope, I need to take the opposite. So instead of negative, it's going to be positive. And then I need to take my fraction and flip it. So 5/6. So it's going to be positive 5/6. Number 3. So we have 3y equals 6x minus 8. It's not quite in the slope-intercept form, so I need to make sure I do that. So I'm going to rewrite it so I can write it in slope-intercept form. To be written in slope-intercept form, I need to undo the multiplication. So I'm going to divide everything by 3. So y equals 2x minus 8/3. So my slope is 2. So the parallel slope is 2, stays the same. If you want to write it as 2/1, totally cool with that. And then the perpendicular slope is you take the opposite and flip it. So the opposite is -1/2, and you flip it, that's your 1/2. All right. So talking about how parallel lines have the same slope, perpendicular lines have slopes that are opposite and reciprocal. You're going to be working on the 7-9 Schoology activity. Have a great day. Bye.